We're going to look at trigonometric relationships in this section. Now, one of the most basic ones is cos and sine. Because of the way we look at the unit circle, you have to remember that cos and sine are related to our x and y values. However, remember the height of the unit circle gives us the sine value, and the horizontal section of the position gives us the cosine value. What that means is you have a right angle triangle where the length of it is 1, thus we have this relationship. So, part A looks at simplifying sine and cos. Now if you factorize out of 2, you might notice that you get sine squared theta plus cos squared theta, which is then equal to a 1 inside. So then we have 2 times 1, which gives us a 2. Then part B, we have, it says show that, so remember you have to start from the left, and we have to make it equal to the right hand side. Now, on the first part, you can factorize out of 3, which you then get 1 minus cos squared of a. However, 1 minus cos squared of a is really a rearranged form of the sine squared plus cos squared, which is 1. What that means is 1 minus cos squared of a should give us sine squared. But if you have a look, there's a sign of a on the bottom. So we can actually divide top and bottom by sine of a, so we're left with 3 sine of a over cos of a. Now I've written down before that sine over cos is just a tan, so we get 3 tan of a, which is what's required. Alright, given that cos of x is equal to negative 1/3, and we look at the region of where it's at, write down the values of sine and tan. Now, I believe we've done this before, where we find the triangle and its position at where it's at, and that will tell us whether or not sine or tan is positive. So it says that cos is in between pi and 3 pi on 2, so we have a triangle here. And for sine, it's always going to be adjacent over the hypotenuse. So what that means is we have a triangle here where we can actually figure out the height. Now, I'm actually going to leave a negative out because we're just looking at lengths, okay? So now this part will be made up of 3 squared minus 1 squared through Pythagoras, which should give us a root 8, which is 2 root 2. So, sine of x is then equal to 2 root 2 over 3. However, sine in this region, if you recall, you have all, light blue is not a good color, all stations to central. Tan's the only one that's positive there, so we need to add a negative in front of the sign. Tan x, we just write out the opposite, which is 2 root 2 over the adjacent, which is a 1. And tan's positive there, so we can leave it as it is. Alright, so there are various other properties. Don't stress, you just have to write them down, and then if you need to, you can draw them out and figure out where they are. So, simplify sine of 3 pi over 2 plus theta. If you look at its position, we always, if you look at its position, we normally rotate around and then we find it based on whether it's at theta, pi minus theta, pi plus theta, and then we have 2 pi minus theta. Now, 3 pi on 2 plus theta is really in this region. So we want to rewrite it out so that we have 3 pi over 2 plus, we want to rewrite it out so that it's 2 pi minus that angle. Now, we can't simply just write 2 pi minus theta, unfortunately. So I'm just going to temporarily change this to pi's. What that means is this will be the same as 2 pi minus some angle that we don't know, and we'll say it's the same as 3 pi over 2 plus, and we'll say that this angle phi is the same as us doing pi on 2 minus theta. Why do you ask? Well, if we go through and we look at the way it's rotating, we normally figure it out this way. However, if we stop in the middle and then add theta, then to figure out this other angle, which is phi, we can just simply do pi on 2 minus theta. Now, writing more of this out, we then get sine of 2 pi minus pi on 2 minus theta. Now, what happens when you have sine of pi on 2? Sorry, not sine of pi on 2. Sine of 2 pi. Sine of 2 pi means we just go back to the start, correct? So in other words, we actually don't need that 2 pi. So let's write out sine of negative pi over 2 plus theta. Actually, I might leave this in brackets. You'll see why in 1 second. On the side, I should add these two properties on. So sine of negative theta is going to be equal to negative sine theta, and then cos of negative theta is going to be equal to cos of theta. So now see how I factorize out that negative? What that means is you have sine, using the rule that I just wrote down, you have negative sine of pi on 2 minus theta, and the reason why we want to get to that point is if you have a look on here, that's equal to cos theta. So that is just the same as negative cos theta. Okay, part B. Give a value for t if cos of 2 pi over 5 is equal to sine t. Now, using the fact that sine of pi over 2, so the same one, minus the angle gives us cos theta, and we have cos theta there, we're going to rewrite this out as sine. So we just do pi on 2 minus whatever angle we have, which is 2 pi over 5. Then we just simply have to work this out in fractions. So we have 5 pi over 10 minus 4 pi over 10, giving us sine of pi over 10.